Problem 1-147. We have a foundation here with loads on top, a distributed load on top, and the ground pushing back up with a distributed load on the bottom. So it says it wants to determine W1 and W2 such that the magnitude of the total load on top will be equal to the magnitude of the total load on the bottom, and they'll be located at the same spot. So let's redraw these two loads in shapes that are analyzable or more easily analyzed. So we're going to use triangles and rectangles because we know the centroid of a rectangle is in the center, and the centroid of a triangle is 1/3 from the big end or 2/3 from the small end. So the bottom here, we're going to make it a rectangle. That didn't look like a rectangle, did it? That's a rectangle. And then we'll make it a triangle. So the width of this is 3, and this is 6, and this is 1.5. So the width here is 10.5, adding all three of those together. The height here of all three of these is 300 pound-feet. And the height of this one, see, it's right there, it's going to be W1. And the height of this one is going to be the difference between W1 and W2. So it's going to be W2 minus W1. Okay, now let's start at the top. So we're going to call this section 1, section 2, section 3. So the load on 1 is 1/2 the base times the height. That equals 450. On section 2, it's just going to be base times height, 6 times 300, or 1800. And P3 is 1/2 the base, 1.5, and the height, which is 300. And that equals 225. So next we're going to find is the location of the load on each one. So this one is going to be 1/3 or 2/3 from the end, which is 2. And we're going to go from point A. So x2 is from this point, so 3 plus half the way 3 is 6. And x3 is going to be equal to 3 plus 6 is 9, plus 1/3 of that. 1/3 of 1.5 is 0.5, so that one is 9.5. So if we add up all three loads, 450 plus 1800 plus 225, and that equals 2475. Now to find the location, x bar, we're going to do the load times the distance summed on the top. So 450 times 2 plus 1800 times 6 plus 225 times 9.5. We're going to divide that by the total of the loads, which is 2475. And so that equals 5.6 feet. So now we have the load, we have the location right here, 5.6 feet from the left, and the total load of 2475. Now we need to find the values for W1 and W2. We'll give the exact opposite on the bottom. So let's look at breaking this into two. So we have the load of the rectangle portion and the load of the triangle portion. So the total load is equal to 10.5 times W1 and then 1/2, because it's a triangle, of 10.5 times W2 minus W1. And we know that that is equal to 2475. Now if we distribute this, 1/2 times 10.5 is 5.25. We can distribute that so that it becomes a positive 5.25 W2 and a negative 5.25 W1. And this is 10.5 W1. So if we subtract that from that, we get 5.25 W2 plus 5.25 W1 equals 2475. Then let's divide by 5.25 and move the W2 to this side, and we come up with W1 equals 471 minus W2. Now let's write the equation for x bar. So x bar equals the area of this one times the distance. So the area of that is 10.5 W times the location, so that's half that, so 5.25 is that distance. So again, we're multiplying load times distance. And then we'll add the next one, which is the triangle portion. So it's going to be 1/2 the base, 10.5, times the height, which is W2 minus W1. And then we'll multiply that by this distance here, which is 10.5 times 2/3. So 10.5 times 2/3. And we'll divide that by the magnitude of the whole thing, which again is 2475. Now all I'm going to do is clean this up and put this in for W1, and we can solve it. So if we, and this equals 5.6, multiply the 2475 times 5.6, and we get 13,860 equals, and we're going to multiply those two out and multiply this times this, and we get 55 W1 plus 37.8 W2 minus W1. Okay, now let's combine the W1s, and we get 13,860 equals 17.2 W1 plus 37.8 W2. Now we'll take this and put it into there, and we get 13,860 equals 17.2, 471 minus W2 plus 37.8 W2. Now if we distribute that and combine the W's 2's, we get W2 is equal to 280. Putting that into there, subtracting, we get W1 equals 191.